Hello students, welcome to Math&Magic. For this video, we are going to solve systems of linear equations by elimination. By definition, a collection of two or more first-degree equations, each containing one or more variables, is called a system of linear equations. To solve linear systems into variables x and y, we have to find the ordered pair xy of real numbers, also known as the solution set, that satisfies each equation in the system. Here, we can use various methods like graphing, elimination, substitution, and Cramer's rule. For this video, we will focus on elimination. This method is appropriate to use whenever we have equations whose numerical coefficients are the same for a given variable, just like in example number 1. Find the solution set of the system 2x plus 3y equals 8 and 5x minus 3y equals negative 1. As you can see, both numerical coefficients for y is 3. And since one is expressed as sum and the other is difference, adding both equations will eliminate variable y. That will give us 2x plus 5x be equal to 7x, and 8 plus negative 1 is positive 7. Dividing both sides by 7 in order for us to get the value of x, that is now 7 divided by 7 or positive 1. Now, after getting a value for one variable, you may substitute this to any of the two equations. Here we'll use 2x plus 3y equals 8. 2 times positive 1 gives us a product of 2 plus 3y equals positive 8. Transpose positive 2 to the right side will now become negative 2. 8 minus 2 is positive 6. 3y equals positive 6. Dividing both sides by 3 gives us a value of y that is positive 2. Hence, the solution for this system is positive 1 and positive 2. Observe that if these equations are plotted in a Cartesian plane, their point of intersection is at point positive 1 and positive 2. Hence, we can say that our given values for x and y are correct, since the point of intersection gives the solution for the system. Also, another method to check whether your answer is correct or not is by substituting the values for the solution set to the second equation, the one that you didn't substitute. If that would yield to the constant that is on the right side, then the solution set is correct. For our second example, determine the solutions of the systems 5x minus 2y equals 19 and 5x plus 5y equals 5. As you can see, it is easier to eliminate variable x since they have the same numerical coefficient, which is 5. And the appropriate operation to be used is subtraction. So changing all the subtrahend, equations now will become 5x minus 2y equals 19 and negative 5x minus 5y be equal to negative 5. Now adding the two equations, positive 5x and negative 5x will be eliminated. We have negative 2y plus negative 5y, which is negative 7y. Positive 19 plus negative 5 is positive 14. And then dividing both sides of the equation by negative 7, y value now is equivalent to negative 2. Substitute the value of y to the first equation, 5x minus 2y equals 19. It will become 5x minus 2 times negative 2 be equal to 19. Negative 2 times negative 2 is positive 4. So the equation is 5x plus 4 equals 19. Transpose positive 4 to the right side. That is now negative 4. So 19 minus 4 is 15. Then dividing both sides by 5 will give an x value of positive 3. Also, when plotted into Cartesian plane, the point of intersection of these two linear equations is at positive 3, negative 2. For our third example, determine the solution of the systems 3x plus 2y equals positive 2 and 4x minus 3y equals negative 20. As you can see in this system, the numerical coefficients of the terms which has the same variable are different. For variable x3 and 4, for variable y2 and 3. What we can do here is to multiply a constant on both equations. For the first equation, 3x plus 2y equals positive 2, we may multiply positive 3. For the second equation, 4x minus 3y equals negative 20, we may multiply this by positive 2. First equation now will become 9x plus 6y equals positive 6. Second equation will be 8x minus 6y equals negative 40. Now, as you can see, the numerical coefficients of the variable y are now the same, and their operations are different. One is expressed as sum, one is expressed as a difference. Here, adding the two equations, variable y will now be eliminated. 9x plus 8x is 17x. 6 plus negative 40 gives a sum of negative 34. Dividing both sides of the equation by positive 17, x will be equal to negative 2. And substituting this value of x to either of these two equations, say the second equation, 4x minus 3y equals negative 20, that would be 4 times negative 2 minus 3y equals negative 20. 4 times negative 2 is negative 8, and if we are going to transpose negative 8 to the right side of the equation, that will become positive 8. So negative 20 plus 8, that is negative 12. Dividing both sides by negative 3, y value now is equal to positive 4. Hence, the solution for this system is negative 2 and positive 4. For our fourth example, determine the solution of the system 2x minus y equals 5 and 2x minus y equals negative 1. Here, we could eliminate variable y by subtracting the second equation by the first. But if we are going to do that, variable x would also be eliminated. Also, if we will rewrite these equations in slope-intercept form, the first equation would become y equals 2x minus 5. The second equation is y equals 2x plus 1. Notice that the slopes of the two equations are the same and their y-intercepts are different. This means that the equations form parallel lines, in which case we have no solutions for this system since there is no point of intersection. For our last example, example number 5, find the solution of the system 5x plus 4y equals 9 and 10x plus 8y equals 18. Multiplying the first equation by 2 gives us 10x plus 8y equals 18. Then copying the second equation, notice that the two equations now are the same. This implies that the two linear equations are coinciding, in which case we have infinitely many solutions. Thank you for watching. Please do not forget to like, share, and subscribe. God bless.